KAUST and McLaren work together like no other. They're both innovators in their field. And one thing that we're both passionate about is the science behind this sport in both on and off the track.
One of the major differences between a university and a Formula One racing team is the time scale. A university typically develops research over many months or years and might have impact on society over 5 to 10 years down the road. But a McLaren Formula One racing team develops innovations every 15 to 20 minutes. And tries to implement that in a vehicle the same day and then race it the next day and test it on the track and then finally have it ready on race day a week later. So the time scale of innovation is very different, and that then makes for new types of ways of thinking and out-of-the-box thinking, both for the researchers in the university but also the researchers and the engineers in the Formula One racing team. To me, it's always been an engineering race. The vehicles are highly efficient, they're highly engineered for safety, for speed, for sensing, for comfort for the driver, and all of these things are in the context of a motorsport with millions of fans around the world. Formula One is a story of pushing the limits of science and engineering, and that's what KAUST is about as well. The best way to train the future engineers is to bring them to McLaren, take the knowledge from universities, apply it into F1 team and vice versa. Individuals that are embedded in the Formula One team will also allow them to make new innovative solutions.
Formula One is a very fast-paced environment where they really are living on the cutting edge of the technology. So when we engage with them, we felt right away that they really wanted to go fast to get the best technology and to win the race. So the goal is to enhance the performance. So they will exchange with us technical data, shape of the car, shape of the front wing to do aerodynamic simulation, and from our side we provide results and provide the tools to perform better aerodynamic simulation. The Formula One car is an extremely complicated object. In my opinion, one of the most complex aerodynamic objects created by humankind. If you can enhance the performance of this car, shaving down 0.01 second per lap, then we can use the same technology for supercar and car with a combustion engine or electric car. So you can see that the front wing of the Formula One car, it's like a wing of an airplane. So for an airplane, you want the wing to generate a force that pulls the airplanes up. When the car turns at 320 kilometers per hour, it could fly, it's like an airplane. Based on the way the air moves around the car, they're going to generate forces, pressure change, shear stress. If you sum them up, they generate a down force to keep the car onto the ground. And they're also going to generate the drag that push the car back. That's what you want to minimize.
Formula One has developed many things which we now take for granted in your everyday road car. Things such as anti-lock brakes, traction control, paddle shift gearboxes, and even hybrid technology has been developed in this sport.
Formula One has taken technologies from a very niche motorsport application to eventually all vehicles on the road. One of them being seat belts, roll cages for safety. So Formula One vehicles are traveling at 300 plus kilometers an hour, and the driver is remarkably safe. So those safety features of vehicles have been implemented in road vehicles. Hybrid electric vehicles, vehicles with lower carbon footprint are now becoming widely used in road automobiles, but it all started in Formula One. Formula One has been hybrid electric for many years. That allows the best performance of the engine and also allows best performance of the battery electric powertrain that's coupled to it. The engines that are used in Formula One have very high efficiency. They're about 52 to 53% thermal efficiency, whereas road vehicles are still in the area of 30 to 40%. So these new technologies that are happening in Formula One, high efficiency engine, are slowly being implemented in road vehicles. Here at the Clean Combustion Research Center, engines such as these, which is a Volvo truck engine for road applications, are being adapted with Formula One relevant engine technologies to operate at higher efficiency.
If you look at the shape from an external point of view, the breakthrough was really, understanding better the aerodynamic of the car. At the beginning, Formula One car, they were like the shape of a rocket, of a bullet. If you compare that shape with the shape that we have right now, it's totally different. The first aerodynamic problem that we were asked to solve was the flow around the delta wing. This is the wing that usually is used for supersonic aircraft. They had the shape of a triangle. Why? Because it generates lift, the force to stay up. It's very similar to what you observe around the front wing of the Formula One car. So there is a generation of these vortices that are extremely important to capture because they are responsible of downforce for the Formula One car and the drag of the car itself, or at least of the front wing.
The sport of Formula One is evolutionary. Year on year it changes, technology's changed at an alarming rate. So between KAUST and McLaren, how can we be the pioneers of developing technology in this amazing sport?
We start off pen and paper, board, deriving equation, understanding the physics behind the fluids that is moving around the car, try to fulfill the fundamental properties, the physical law behind that, and then we implement it into a high-performance computing framework. We run it on a full machine, full Shaheen, about 200,000 core for about 3 weeks. We were even simulating, the driver with the helmet, the tire. So it was a very realistic model that we simulate, and this is thanks to the supercomputer. And this software provides them the solution, how the air moves around the car.
We had to develop faster algorithms and more robust tools to do fuel design to get solutions within a matter of hours. And we developed those algorithms, those tools, and we did this by moving away from traditional theoretical computing techniques more to artificial intelligence-based techniques that were trained on the theoretical models. And then the same way the engineers in the Formula One racing team, rather than thinking about what is a solution that's going to help me in the next 15, 20, 30 minutes, let me take a step back and think, okay, if I invest my time and my knowledge into developing something, maybe we'll have something much better 1 or 2 months down the road. So the university researchers got the engineers to also think on a longer time scale, rather than just what's happening in the next race or what's going in the vehicle in the next day. What can we innovate on in the next year, the next months, to have huge advances for the team several years down the road.
One of the most critical elements in this sport is fuels. McLaren and KAUST are pioneering in the research development of fuels, not only for now, but also for the future.
McLaren has been awarded the most sustainable team in Formula One for many years, but they're also looking to the future. And KAUST is a university which is developing many sustainable solutions, not only around energy, but environment, food, water, and Formula One. They have many guests coming to the track. They want to provide those guests with a sustainable experience. Many times they're using carbon-intensive technologies for moving the vehicles, for moving the team. They need to travel around the world, and anything related to new types of carbon offsets, new types of nature-based solutions for dealing with carbon emissions, more innovative types of materials that are used to be more sustainable in terms of plastics. Many of our sustainability initiatives, our climate and livability initiative at KAUST will be relevant to McLaren, and we hope to develop the partnership further in that direction over the coming years.
If we can improve the aerodynamic of the Formula One car, we can improve the aerodynamic of supercar and then of the car that we use on a daily basis. That means that we are going to consume less fuel, we can reduce their emission. So we are going to pollute less, which have a strong impact on pollution, and this is an important factor in terms of sustainability.
So what is next for McLaren and KAUST? Well, the answer is anything. We're pioneers, we're innovators. The future is not written yet, and that is what KAUST and McLaren are here to do, is to write the future.